I got a really cool video for you today. This is part 2 about turning an air conditioner into a walk-in freezer. We're going to be using this wine cellar here, and I went over the design in the first video of how exactly this is working, but I just wanted to quickly briefly go over the summary of it all and why I'm going to be pointing at certain things so you can understand exactly what I'm pointing at when we go over to the air conditioner. So in front of me I have a thermostat. This one is a different thermostat. So a normal air conditioner, we'll say, has a little bottle of mercury, and as the temperature increases, the mercury will actually increase. And so mercury has a very large change in volume for a change in temperature. The same thing with alcohol. So when we look at those little thermometers now with the red liquid, that's actually alcohol in a vacuum. So as the mercury increases with temperature, it'll turn the air conditioner to turn on. And then we get into newer air conditioners that have something like a thermistor. So as the resistance changes, the air conditioner turns on. And so I'm going to show you that this is just like a wire that goes across, and we're going to look for something that looks just like that, a thermometer. And then we have, instead of a temperature volume curve, we're going to have a temperature resistance curve. So in front of me I have a thermostat. If you notice this thermostat, it has these two little heating and cooling levers. If I push this here, they go together. And so this is telling it what temperature to turn on and off at for the unit. And then in this door here, it has a little thermostat as well. So what's kind of cool about this is it has an electrical one in the door, you could say, and then it has the mercury one right here. So inside the door, if you look really close, this little spool of wire, as it gets hotter or colder, it'll bend this needle at the top in a certain direction. And that's kind of like the idea of the resistance. And then if we look at the back cover here, you can see that those two are connected by the bar right here. But if we look down here at this bottle of mercury, it's actually a little bit of mercury inside of here. And then as the mercury expands, it'll touch the needle. So there's different locations to where it'll make contact. So now let's go over to how I modified this air conditioner. And we're going to be using a air conditioner right here, and that's the thermistor pulled out. So that little wire that I talked about in my diagram here, let's get this set up. So we talked about how the mercury, as it increases in its volume, it turns on, and now we have an electrical unit, which is the one to the right, which is kind of like the wire that I showed you over there. So what we're going to do over here is we're going to take probes and attach it to the thermistor, the wires that come out of it, and we're going to measure the resistance in ohms on our meter and record a temperature in degrees Fahrenheit. We're going to use a couple checks to make sure that we have the correct temperatures and resistances, and we're going to get our two values, X and Y, two of them, and then we're left with an equation down below. Sorry, we're going to get to that in a second. So these are the two values. So we're at 70.8 degrees and 69.7 degrees. We were left with 6,500 ohms and 6610 ohms. And then we're able to use a slope slope-intercept formula to calculate the equation. And the slope-intercept formula is the y is equal to mx plus v, which you're used to. And then that left us with the equation here, where the degrees temperature and ohms here are our two variables. So for a given temperature, there's a given resistance, and for a given resistance, there's a given temperature, based off of those two previous values that I talked about. I'll show you in a second the math behind that. So at 40 degrees, we get 9630, and at 60 degrees, we get 7630, based off of this equation. So this isn't an actual. The ones that I showed you right here, those were actual. So therefore, the difference that we need to do in order to trick our air conditioner to thinking it's hot is actually inversely related. So we need to subtract 2000 ohms from the resistance. If we were to say that it's 60 degrees in the room, then the value would be this. But if it's actually 40 degrees, so the only way to get from 9600 to 7600 is to put it in parallel. Because if you were added in series, or resistors in series, it would increase the resistance. So this is the formula then that we need to go off of to calculate our needed resistance at 40 degrees. And then we have our given resistance at 60 degrees. And then what resistance would we need to attach to our thermistor? Be 36,700 ohms. So we're going to look for a little probe like this. We're going to have to put it in parallel. And that value is going to be 36,700. And then this little resistor value that we measured at 40 degrees is going to be 9630. So it's not 40 degrees in this room right now, so it's not going to be 9600. And so then when we give 7630 ohms at 60 degrees, but it's actually 40 degrees, we do that math, that all looks like this. If you guys want to see it, I'll just show you guys so you don't have to watch it. Right. So over here, I'm just going to briefly show you guys, and then I'm just going to do a detailed walkthrough. So this is the thermistor that you were looking at on if the air conditioner were to turn something on. That's the air conditioner. So my phone dies. We're going to have to cut this into a new one, but I'll keep going. So remember how we talked about the thermistor? That's it right there, and it normally just runs through, and this is what tells the air conditioner when to turn on and off, because this senses temperature, kind of like a bottle of mercury. I pulled out the screen there, or the filter you could say, and I looked inside, and down inside this here was where this was located. Because how an air conditioner works is it sucks air in through here, and it spits it out through there. So the intake here measures the room temperature, which is what we're trying to trick it into thinking it's hot. So if you follow these two wires now, if you were to follow this side, these two wires come down, and they have a resistor. You can't see it, but it's behind the grill there, because it's too dark. And it comes down here into a switch. And so I can turn on or off this. It just opens the circuit right here. And what that looks like on paper, if I can find it, is something like this. So our air conditioner turns on and off. There's our thermistor. That's the 3700 ohms. But then we add our switch. So now I can turn on and off our modifications like I showed you. So hopefully this goes about 20 degrees offset. And I'll be able to test that when this is on. So hope you guys enjoyed this video. Thanks for watching.